take very long, especially with the demo in tandem. So what I'll try to do is talk through, what I'm going to do on the demo, and we'll just kind of go from there. So let me share my screen and let me know when you can see it, if you don't mind. Okay. Are you all able to? Okay. Do you see the new screen now? Is it a different screen? Okay, cool. So it works. Okay. So let me just kind of show you what we're going to do today. So in the previous session, I talked about, data lake overview, right? So that was, for those who weren't here for that session, the data lake is really just, a paradigm and an architecture that allows you to persist raw data, hence the word lake, uncurated data, building a way to either through batch or stream land data in AWS. And from there, you can do all sorts of downstream processing, right? So machine learning, data warehousing, loading data into databases, migration efforts, what have you, right? Or building dashboards. So today we're going to focus more on the ETL side. I'd love to get to the visualization piece, but at the minimum, what we're going to do is, walk through what ETL looks like. What does that data movement look like within a data lake, from a, bringing data in perspective to any compression, which happens on that data to kind of reduce the footprint, as well as, taking that data and performing some sort of lightweight querying from that data, right? So, I don't want to bombard you all with too much in one session. I really just want to convey the ease of use and the tools that we have to make this process a lot easier for customers. So let me talk about what I've already completed. So I stood up a database, a Postgres database, had some sports data in it, had about 17 million rows across all the tables. So it's a pretty big database, has a lot of real data in it. And what I was able to do is I used a service called Database Migration Service to bring that data out of Postgres and into the data lake. So right here, right? And I was able to bring that into S3, which is our simple storage service, our object storage. So now with that done, the question now remains, okay, you have this data in S3, in a CSV. So now what, right? Now, how do I, expose this for processing? How do I build a data pipeline in which I can compress that data, build some sort of logical tables that help me understand what is in that data? Because again, a common concept of the data lake is that there is no defined schema on the data lake side. It's object storage. The schema is defined on read. So one thing you're going to see during this demonstration is, when we're building logic to understand these tables, the first concept is a crawler, right? And a crawler, what it does is it goes against the source repo and it understands and discovers the schema, right? And I've built one already for the CSV just to kind of expedite the time. We're going to do the same on the Parquet side, and I'll still walk you guys through, but I just wanted to make sure we can get as much done as possible in this time window. So after the crawler runs, the next thing that happens is it creates a data catalog, right? So the crawler crawls your data. It has built-in classifiers. It can, understand, common file formats. And because I was coming from a relational database, I actually preserved my column headers. So the schema definition was a lot easier for my crawler. You also can edit the schema definitions that the crawler discovers, and I'll show you how you can do that as well. But just know that crawler is really producing a logical data catalog on top of that object storage, so that downstream applications understand what data is, where data resides. And they can use that schema, that logical schema, to be able to do things like queries, for example, or, loading or bringing data into a data warehouse, right? You want to understand where data resides. So that's essentially what this process will be. We're going to walk you through various screens, and, we're going to do this live. So excuse me if anything breaks. That's the curse of live demos. But let's just dive right in. So let me show you what I already have for starters. So again, let's start with S3. So if I look at my data lake, and this is a very, pseudo data lake, if you will. I have a directory called tickets, right? So I click this directory, and DMS sample is where I loaded all of the tables from Postgres. Okay, so this is an extract straight from that migration service, that database migration service that I mentioned. It brought data directly into S3. Okay, and this is, essentially where I'm persisting, the rawest of the raw data, right? Now, the second step is, well, I want to do some compression on that data to kind of reduce my data footprint. Some customers may get rid of this data after it's compressed. You definitely have that choice. So what I did is I made another directory, and it's called DMS Parquet, Database Migration Service Parquet. And I have the same structure. And essentially what I'm doing here is I'm taking those files and I'm landing them in this directory, and I'm compressing them as well. Now, along with this, you can apply multiple different types of transformations. For starters, we're going to start pretty basic just to understand the workflow. And then you'll quickly see how much you can mature, from this foundation. So let's go ahead and piggyback off of what I've already done. So let me just show you one thing. I already did one file, right? So I was able to take all of the data in the sports team directory for the raw data, and I ran an ETL job that landed the compressed version in this folder, right? So what we're going to do is we're going to go through that for all the other tables, and within each table, there are going to be many transformations, meaning that we're taking some source data types and converting them to others, and vice versa. Well, not vice versa, but we're going to be doing multiple different types of transformations. So I want to walk you through that just to kind of get you to have an understanding of the different components of, how you can build native ETL within AWS. So we're going to go over to the Glue console, and Glue is that fully managed ETL service. As you can see, I have that Glue crawler here. This was my first crawler that went against the raw data, so that data that came directly in from Postgres. And this actually created what we call the table. So this is my logical table. I created a database called ticket data, and this exists within Glue, right? So this is that data catalog. And these are all the tables that were discovered by Glue, right? So if I click one, sports team, right? So here are the fields that it found, the data types that it inferred, and you have this ability to edit the schema. So for example, there was a situation where one of my column headers didn't propagate, and I did it on purpose. I already changed it, but it said column 1. It said col 1, right? So, you can just go in, change it, and update the schema, right? So it's pretty easy. You also have versioning. So what you could do is, if you have applications that depend on this logical schema, you don't have to, break that binding. You could just create new versions of the, basically the same backend data, but just a different table, right? So you can have as many logical tables on top of the same source as you want, which gives you flexibility when you're building pipelines, right? So this is how you can kind of manage dependencies that applications may have to certain schemas that you define within the data lake, right? And again, the biggest benefit here is that, in the relational world, this is hard to do, right? You can't just up and change a SQL Server schema without going through a lot of, without the ripple effect taking place, right? It's going to be a massive overhaul. So with this, again, it gives you that flexibility that as you're defining new data sources, as your company grows, you're bringing in sensor data, IoT data, maybe even just more customer data. Maybe you acquire a SaaS platform, you want to bring that into your data lake, and you want to integrate it with some other data. You have that ability to do on the fly, right? So this is really, one of the biggest benefits of the data lake. So enough of that. Let me pivot over to the jobs, and we're going to create a job for the rest of our tables. Okay, so we created one for that one table. I believe the name was sports team or sport team, sorry. And now what we're going to do is we're going to do the same for these other directories, right? So for all of the corresponding directories in the raw directory, we're going to build ETL jobs to do the compression as well as some lightweight transformation and land them in this directory. So what we'll do is we'll go to jobs. And as you see, I have my first job, so glue sport team parquet. So let's add a second job, and then I'll just kind of explain, what these options are. So as far as a name, let's call this one, let's call this guy Glue Lab, Glue Lab Sporting Events Parquet. All right, so when you're configuring an ETL job, you give it a name. It's pretty simple. You also give it an IM role. This is just a role that has access to the sources involved in this job, right? So in this case, it's S3 and Glue. So this role that I provisioned before, we joined the call already has access to these services. You also have the ability to basically use a script from Glue. So Glue generates code on your behalf, which is why I think it's very useful for folks who aren't data experts, because you can even use it as a baseline to build your own custom logic. But again, it does a lot of inference based on selections that you go through in this phase. So I'm going to select propose a script generated by Glue because I'm going to click a bunch of options, and I want Glue to pretty much do a lot of the work for me. So let me go next. And let's choose a data source. So I did this for sporting events. So let's go ahead and find that table. Awesome. So we have that. So this is that, CSV. These are CSV files. They reside in that other S3 location, the S3 bucket or folder. I'm going to click those. And as far as the schema is concerned, we're going to change the schema, right? So we're going to do some manipulation to the schema, and we're going to create new tables in my target, right? My target is S3. My compression type is, my format is Parquet. And the location is going to be the corresponding folder in S3 with the same name. So that sporting event Parquet folder under that Parquet directory. So I believe that should be here. Yep, here. We're going to Parquet, and then we'll select sporting event. All right, so pretty straightforward. You select that folder, you click next. All right, so here's how you can do some lightweight transformations. So with this one, we're going to change a couple of fields. The first field is the start date time, so that's a string. What we're going to do is change that to a timestamp. So, all we do is come in here, and we'd say, wrong one. There we go. Change that, timestamp. All right, so now we're telling Glue, hey, when you build my script, I want you to change this field to be a timestamp. Easy enough. Second thing we're going to do is we're going to change the start date as well. So let's go to start date, and the type is string. What we're going to do is change that to a date, right? Because dates are a lot more easier to use in that context. So let's see if we have a date. There we go. Have dates. We'll click update. Right. So here we made some lightweight transformations. Nothing special. But again, Glue uses this and does its own thing and makes the scripts, and I'll let you get a look at that as well. So we have our transformations. Everything seems to be in order here. So what we'll do now is we'll go ahead and author this job. So we'll just say, okay. Save the job, edit the script. So here's the actual code. So based on the configurations that we put in, Glue actually generated these mappings for us. Now you can also go in and add your own logic on top of this. So as you can see, here's the high-level workflow. Glue is going to apply the mapping. Then it's going to resolve choice. Resolve choice is, that's an interesting one. So imagine, since this is a flexible data structure, Glue uses what we call dynamic frames. And what that means is that these frames can hold any data type, right? So when you think about, for all those who may know Spark, it uses data frames. Data frames are highly schema heavy. So, data that resides in a frame is tied to a schema. Dynamic frames are similar, but you can kind of put elements within a frame that don't have the same type. So with glue, what it does is, because it's built for data that you are trying to discover, even though you can use it on structured data, it's built to understand data that you are, have no idea what's inside of it. It allows you to, have multiple data types or data objects within the same frame that are of different types. So imagine if you're, doing some data processing, you realize that you have the number 2 and the word 2 in the same field, right? For some reason in your system, glue wouldn't throw a fit at that. You'd be able to resolve and either cast it to be a digit or turn it into a string, right? But it would still preserve and give you the choice, when certain scenarios like that arise, you can build your ETL job to handle it, based on the data and the way, the data is structured, right? So, again, glue, gives you a lot of that flexibility. And then we also have the last step is dropping all fields. These are out of the box. You can customize these workflows as you wish. But we'll keep it simple for today and just allow the out-of-the-box code to run. So let's go ahead and run that job. All right, so let's close that. I will say that glue, in the background, what you'll see, let me go over to the job. So this one is running. Okay, this is what we did. Okay, so with glue, there is the notion of a cold start, mainly because, as you can already see, there is no infrastructure that you manage. So the cluster that runs your job is being provisioned on demand. Once you actually run your job once, the second time you run it, it's pretty immediate because your cluster is warm. But the reason I have a cold start is because, I'm doing this live, right? And I didn't already pre-create it. So first time it runs, it spins it up. And then after that, you're pretty good to go as long as you're running it at a valid frequency, if you will. So what we'll do is while that's doing its thing, we'll go in and do the other tables, and we'll walk through the same process. We'll do some transformations. Some are pretty straightforward, and some are just direct mapping. So let's get that done, and then we can I'll take questions, and we'll talk about some other ways to extend this, and then if we have time, I'll move into the ways you can query that data and kind of produce some analytics. So on that note, let's go back to jobs. We did sporting event. Let's go ahead and do sporting event ticket. So similar process. It'll become muscle memory for those who end up taking this route. Sporting event tickets parquet. Again, IM role pre-created just for time purposes. I already made it. I'm going to use the proposed script. I'm going to go through, click next. I'm going to search for the data source on sport team event ticket. All right. So I'm going to take that from my source directory. Change the schema on this guy, IM. We're going to create new tables in my data target. Our target is S3 again. Compression type, format, parquet. And we are going to target path, same as the other one, just the specific directory for sport event ticket. Yep. Okay. Select that. Click next. Okay, so here's my mapping, right? So again, this is coming from that logical glue catalog that Glue created. Now for this one, we're going to make a couple of changes. The first one is going to be on the ID. We're going to take that from a string. We're going to make that a double. So pretty basic. The second one is we're going to turn the start date. No, I'm sorry. We're going to turn the sporting event ID also into a double from a string. And we're also going to take the ticket holder ID, right? And we're going to do the same with that one. So this is, again, just very, very minor derivations or transformations, if you will. And we're going to do the same thing. We're going to save the job. And we're going to, the same structure of the code. Not really making changes to the workflow, kind of out of the scope for today. But again, You do have full flexibility in the way you orchestrate these jobs. You can have multiple jobs kind of spit out in the same place to kind of give you a holistic view of data as well. There's definitely reference architectures on that. So let's go ahead and run this job. And I believe we have 3 more. So I'd like to get these to be running so that I can take questions and kind of talk about some other topics while these are warming up. So I think this one is still running. Okay. So let's move on to the next table is the person table. So we're adding another job. We'll go to glue, lab, person, parquet. Again, muscle memory, IAM roles are going to be pretty common in any service you use. You're going to have to give access just so that, we allow you to manage the way services interact. That's a customer responsibility by nature of the platform. And we're going to be looking at the person table. Okay, take that one. And same thing, we're going to make a minor change to the schema. We're going to create new tables in our target. We're going to use Parquet format. And we are going to output it in the same place as the other one. So we'll go to person, and then we'll click next. And here's the mapping for my person table. Pretty straightforward. Just going to make one small change. We're going to change the ID to a double. So we'll take this guy and go ahead and transform him into a double, update him, take the job, edit the script. Let's run this guy. And I believe we just have one more. Run the job. Awesome, get that running. We have one more. This one is relatively easy. We're not actually making any changes. We're just bringing it as is. So let's just get that one out the way. Sports, location, parquet. Same thing, muscle memory, IAM roles, script proposals, allow Glue to do its thing. This one is sports location, right? Okay, go there, select it. We're not gonna change the schema, right? So we're just gonna leave everything as is. Once we get to that screen, we'll still do the directory so that it lands in its proper directory and be in one. Okay, sports location. There we go. Okay, connection. So we're not going to make any changes. We'll just let it be as is. We'll just run this guy. This one is actually all good to go. So let's do that. All right. So while that's running, I'll walk through what happens next. So after you discover, turn back to this picture. After you run, so we did this. I did this part before you guys joined. I ran the crawler. We had the data catalog. So I showed you the tables within Glue. That was the data catalog. The third step is the ETL, right? So here's what we just did. We just made, from the CSV, we built ETL to bring it into the DMS Parquet, right? And now we're going to do after that is we're going to run the crawler to then crawl this directory so that this can be leveraged, this catalog. We can expose the Parquet tables, right? The Parquet tables from that catalog to downstream systems like Athena, for example, right? Athena can query against this table as if it's a native, SQL schema, right? And Athena is our fully managed querying service, right? So very deep integration with the platform. So while that's cooking, what I'll do is, first I'll just open the floor for questions. If not, I'll go into just some best practices with using the ETL services. So I'll take a pause here and see if anyone has any questions or, maybe some considerations you want to discuss. All right. So it seems like silence is a good thing.
Corey, quick question. Corey, this is Greg. So for all the people out there who are watching, if you look at if you can go to your third tab, the lab. So if you look at the URL there, everything that Corey is walking through is actually one of our public facing workshops. So if this is something that you're interested in actually taking a deeper dive in to look at some real world examples and walk through, all that data is out there for you. So the only reason I bring that up is sometimes I have found in the demonstrations, I like it, I get excited about it, and then I forget what was going on. So I just wanted to point out that AWS data engineering day workshop.aws. And so it goes all the way from the beginning, right? You can see building a data lake, and right now we're doing the transformation. I do want to say there will be costs associated with this. So in your account, there are ways to set up your account to be able to get alerts for cost and whatnot. But I just want to make sure that people, if they wanted to read about this later on, knew where to find information. So with that, I'll turn it back. Thank you, Corey.
That's a great point, Greg. So yeah, if you want to dive deep, and there's a lot of things that I'm omitting from this discussion, mainly because I just want to scratch the surface. I don't want to open the fire hose, right? I want to make sure everyone has the chance to digest the basics. But again, there's a lot of optional labs in here as well that you can leverage to, dive deeper into these concepts beyond just minor transformations, right? We have examples that go deeper into, data scrubbing. So again, feel free to look around. And again, if you have any specific questions, we can definitely provide some insight based on what we know. And if we don't know anything off the top of our head, we can definitely follow up. Cool. So let me just go back to the console, and I'll talk through some best practices as this guy runs. I think it's probably still warming up. Well, let me just check the status of these. So this one succeeded. This one's running, and running. All right, so we have some time. So what I'll do is let me just turn on some slideware. I guess you can't escape the slides. I'll just keep you busy in the meantime, and we'll talk through some best practices. So let's go ahead and do this. Let's go ahead and I'll keep my eye on the watch so I don't kill you with slides, but, I want to make good use of this time. I think it's some good stuff we could talk about. So let's talk about, what do we want to talk about? We want to talk about this. This is exactly what we want to talk about. All right, so let's pull this up. I'm going to show you a couple slides. Everyone can see my screen still, I assume. Yeah, I can see. Okay, screen sharing. Cool. So when you're thinking about ETL, let me see the time check. Sorry. So it's 1:45. Okay, I'll go until 2, and then we should be wrapped up for that ETL piece. Okay. So when you think about ETL, right, and optimizing for cost and performance, there's a couple of things to keep in mind. When you're landing data in S3, for those who are knowledgeable of partitioning, that is crucial because this is essentially the logical structure, or actually it's like a logical structure / physical structure of how you're storing that data, and it correlates directly to performance. And I'll get into examples. And as you can see, there's an example structure of how you can optimize the lookups, based on the way S3 runs. Being an object storage by nature, partitioning and this logical separation helps, that lookup time for S3. Compression, of course, you want to reduce your data footprint as much as possible because, again, with the data lake, you're storing a large amount of data in a long, almost like a ledger of data. So you're going to have a lot of it. You don't want to give it up, but you don't want to store it as is. So you can turn a terabyte into a couple gigs, based on what compression algorithm you use, which is very useful. And then managed services, right? So a lot of these services, as you can see, are managed. So Glue, there's no infrastructure. It provisions the cluster, S3, or the storage service. There is no, allocation of, hey, I need this amount of gigs. You just use it, dynamically allocated, and it just grows infinitely, right? Exabytes of data or storage are available to customers. So let's kind of dive into what this means. So you see it on the left, this is a non-optimized partitioning strategy, right? So, all of this data would be scanned if the S3 was trying to look up a particular file, right? Because the timestamps, you can see them visually, but logically, S3 uses the directories, to store its data, right? So when you just do it in the name, it doesn't give S3 the ability to leverage the power to, at a high level, smartly or intelligently store this data somewhere where it can easily access it with a simple question. So if you look at the right side, I can ask S3, hey, what data do I have during this date period? What data do I have in this country? And S3 can go through a couple hops and find that exact data, right? It finds that exact file. And in the real world, you'll see a large number of files here, but essentially we're just talking about the way S3 traverses, which will directly impact cost and performance, right? So if you look at the runtime examples, non-partition data sets, in this example, 9.17 seconds, partition 2.16 seconds, right? So a large performance lift, which then decreases cost because the serverless cost model, a lot of it is in, time consumption or resource consumption, as well as the amount of data scanned, which is really, a big piece. So if you look at this, you're scanning 74 gigs of data non-partition. When you partition it, you reduced it to 29 megabytes, which dramatically, I've had customers who, begged for credits because they've made boo-boos in their environment where they loaded a bunch of data and their, admins were doing queries or some ETL, and inherently they were scanning terabytes worth of data, right? And there was minimal compression optimization done. So, there was a big cost associated, right? So, as you can see here, the costs are dramatically different, especially for, if you're thinking about large scale, right? This number, absolutely is small, right? 36 cents, I can give you a quarter and some change. But when you're running this, across an enterprise, this easily adds up, right? And you'll easily get a knock on your door from your, vice president saying, hey, look, we got to have a talk. So definitely recommend just understanding the partitioning paradigm. It really helps with the runtime as well as the cost. Compression as well. So there's multiple different algorithms out there. So, you have gzip, bzip, snappy, et cetera. And there's different flavors of when it's different reasons to use, either one. So I'll give you just a quick example. As you can see, well, let me back up for a second. A lot of the services like Athena, for example, that querying service that provides a native SQL query explorer, if you will, to be able to run SQL queries. It uses distributed nodes to read data from, S3, for example, or from your data catalog, right? So when you think about the column splittable, that plays good with an Athena because now the data can be distributed across the nodes that Athena uses to run. Now, it's not a no-go. If your data can't be splittable, it's fine, right? They have, pros and cons. So, for gzip, for example, it's not splittable, but the compression rate is high, right? Which means that I can reduce a terabyte into a smaller amount than other algorithms. So it's good for raw storage, and it's medium speed. So that means that the amount of time it takes for my ETL will be like in the medium range, right? It's not super long, it's not super quick, but good enough. It gives me a good compression ratio, so it's pretty common. Bzip is, similar where it's splittable and the compression ratio is really high, but it's slow, right? And you can imagine why, because the compression ratio is a lot higher. So this is really good for large files, right? If you have terabyte files or like hundreds of gig of one file, that would be a good choice for bzip because it's also splittable, right? So it bodes well with that distributed processing paradigm. And the compression ratio is low or high, so you can reduce that data footprint as much as possible. And it's just a little bit slower. So, you're not going to be able to, run that job is going to take a little bit longer, but the savings you'll get, is well worth it. And, you have to kind of gauge it based on the use case. So, I won't go through all of the options, but this is, sort of how you think about, again, a best practice when you're doing a data lake, what things should you be thinking about? Well, partitioning as, the logical structure, as well as the compression, right? How are you landing these files? How are you managing the growth of that data footprint, right? So again, if you look at this example, because we can turn, gigabyte, 74 gigs, 29 megs, your data isn't going to grow exponentially, right? There's a certain buffer that you can put on it because of the compression. So just keep that in mind. Customers ask, well, if I'm saving everything, then I'm just going to grow my costs exponentially, and that's not the case, right? There's definitely mechanisms to help remediate that. So if you look at compression, check this out. So we have a data, a terabyte of text data. It takes 3 minutes to scan, right? Costs $5, right? $5 a terabyte. With Parquet, I can compress this thing into 130 gigs, right? So that takes 6 seconds to process. The data scanned is oh, I'm sorry. These are actually two different columns? Data scanned. Yeah, this is the same column. I'm sorry. Data scanned is 2.51 gigs, and the cost is 0.13 cent. Right, so just a penny and some change. And this is again what I was getting at with the way your ETL would run. Right, so the way Glue would run is it would have to, go against your data and scan it in S3 to kind of find it, or if you're even using S3 natively. So again, the more you can reduce that footprint, it directly impacts cost. As you can see, $5 is a lot different than 1 cent. This will immediately get your dev environment revoked by your center of excellence. I can guarantee it. Where this one is something that you'll become a shining star in your organization, right? People will love you and they'll want to, maybe bring you on that team. So, I say that jokingly, but again, these are definitely things that I've run into with customers. So, very important to keep in mind. Again, another thing with S3 or the storage, solution that we offer as a data lake is, the fewer larger files are better than many smaller files, right? And it's because they're splittable. So when you think about overhead of CPU, or if I have to make 5,000 different calls to count files, that's 5,000 individual calls that I make. So even if the data footprint is the same, like if I have 1 megabit or 5,000 1 meg files, or just one conglomerate, or just, bigger chunks of the same total storage, because I have to make those individual calls from an S3 standpoint, it's going to take a lot longer. Because I can take that big file and split it, right, within the ETL, I allow the platform to optimize the way it horizontally distributes my data or whatever processing that I'm performing against my data lake, right? So, you have less operations to do because you have less files, and you can still leverage that built-in capability to split those files and run them on a distributed cluster. When you have these very tiny files, again, that IO overhead it grows, and you don't really get to take advantage of splitting files because the overhead to get that set up, you would have already been able to process that small file, right? So you kind of got to play it, on both sides. One common pattern I see is that customers will consolidate feeds that they bring into the data lake. So if you're doing telematics data, you may aggregate data over a time period into one blob, right? And then that blob can be, deblobbed, when it's time to do some sort of, analytics, or you're trying to make it available to someone. But at least when you bring it into the environment, you may have some time series structure logically, and you're aggregating multiple payloads within that blob itself. Or sometimes they bring them in as is, and then they do that in the cloud, and then they'll remove the old data because they already have it, raw in its compressed format. So there's a lot of different ways you can take it. But again, just another thing to keep in mind. So let's go ahead and check on the jobs. I don't want to show you a slide where it looks like it's almost 2 o'clock anyway. So only 10 minutes slide where it's not too bad. Let's see. So this one succeeded. This one succeeded. This one succeeded. This one also is a success. Great. This is awesome. Okay. So no breaks yet. Don't want to jinx it. So what we're going to do is we're going to do this step right here. We're going to create the crawler, and we're going to run against, this newly created DMS directory which has the compressed or, different format of the CSV files, right? And we'll be able to load those into our data catalog and make that available for downstream systems. So what we'll do is, let's go here. Let's go to crawlers. And let's see. So what we're going to do is, I have that one. Let's make another one. Let's call this guy glue-lab parquet. Cool. Cool. So data sources, we are going to select S3. So let's go with S3. As far as the path, we're going to choose that directory, that parent directory, right? So this directory, right? So because we're doing the crawler, it's going to crawl on everything in this directory. So we want to select the parent directory in this case, not the individual directories. What we'll do is go ahead and click next. Add another data store. We will not. We will keep it simple for today. Let's go ahead and update IAM role. So as I told you, muscle memory, get the roles together, make sure you understand access and identity management within the platform. It is going to be your best friend, and also just make you a lot more secure in how you're operating in the cloud as well. So it's a win-win for us both. Frequency, we'll run this on demand, right? So we'll just keep that as is. Database. So we have an existing database, right? So those tables I showed you in Glue are in a database, a logical database, right? That's managed by Glue. So what we're going to do is we're going to add, the Parquet tables to that database, but we'll just give it a prefix, right? So that we can tell which tables are the Parquet tables versus the raw tables, right? So we'll just add this prefix so that on our tables, it'll say Parquet. And we'll just maintain the same names of all the groups. These are just other parameters. I don't want to enable these, or do I? I do not. I do not want to enable these. We'll keep these relative update table definition and cat. Yep. Okay. Got it. Okay. All right. So it'll give you a quick snapshot of your crawler. So again, it's going to crawl against this data store, which is the compressed version of my files. It's going to use this role for security purposes. I'm going to run it on demand, and the output is going to be, in this database, logical database, in the tables, in its own tables, prefixed with Parquet, right? So let's go ahead and click finish, and let's go ahead and run this guy. So we'll just hit run now, attempting to run Google crawler. Okay, so we'll give this some time. And what I'll do is I'll pause, because after this piece, we'll look at the table created, and then it'll conclude the ETL portion, of the presentation. And if you have any, detailed questions, I purposely omitted a lot of the advanced features of Glue. From a transformation standpoint, there's so much more you can do. I mean, I could literally burn you in terminology and examples of all of the crazy things that you can do with Glue, and how you can transform data and manage collisions, all types of things, especially in the world of raw, unknown data, right, that you're discovering. But I don't want to, confuse anyone, so I'll kind of let that come on a need-be basis. So are there any questions, initially just looking at this workflow, thinking about this high-level design, maybe things that you're doing internally in your organization, or, for personal reasons? Are there any questions or gaps in anyone's understanding of how, this can be extended or leveraged for their use cases? Going once, going twice. Alrighty. All right. Silence is good. As long as everyone's awake. I can't see your faces, but I'll assume you're still awake. All right. Let's go ahead and check out, see if this is finished. We can check out these. Looks like it's stopping, so it should be complete pretty quickly. We'll let that get to ready status, and then we'll go ahead and check out the tables it populated. and then we'll talk about the next steps. Let's do a quick time check. Okay, 2 o'clock. Okay. So, okay, cool. We have good time. Awesome. So I have a question for the group. Is there anyone in the room that is, using machine learning today, or, is doing some sort of data pipeline specifically for like a model training pipeline? Just kind of curious. No one? Okay. Fair enough. Okay. Let's refresh. Should be done in like the next minute or so. Give it another couple of seconds. So looks like it added 5 tables. So at least we know it worked. Added 5 tables. You look right here. So that's good. No failures. Let's go ahead and see if it's there. I mean, it says it's stopping, but it might already be available. Awesome. There we go. So let me do this. Let me filter by Parquet. So here we go. So basically within this database, right, this ticket data database that we stored in Glue, excuse me. So within this database that we stored, again, which provides a logical data catalog for metadata that sits on top of raw data. So again, we can feed these tables to multiple downstream systems so that they can have their own experience with how they interact with the data, right? So, in this example, we've, compressed our, CSV data from RDS, from Postgres, put it in Parquet, and then we've built a logical table, Parquet tables, in which we've exposed that now that we can use in services like Athena, et cetera, to do some sort of lightweight querying. Let me make sure this is finished. Still says stopping. Okay, let me just wait. Looks like we have enough time to go through a couple of queries. What I'll do is I'll try to keep it going until around 2:10 or 2:15, and then I'll turn it back over to Justin and team to maybe do any wrap up or sort of closing activities. So let's do this. In the meantime, I'll just ignore this guy. We'll just assume that he's done. I think he's pretty much done what he has to do. Tables are there. We're gonna go ahead and push forward. We're gonna push forward. So let's go ahead and look at Athena, so we can go ahead and see some cool things we can do with this newly discovered data, if you will. So let's go ahead and open Athena. All right. And if you're a noob like myself, you'll see this getting started because I have not got started on this account for Athena, that is. And for those of you who are familiar with Hive, I don't know how many of you are in the big data space. Athena is very similar from a UI standpoint, so it looks almost the same, actually. And it is the same experience, right? So you can write your queries, you see your databases that are connected, right? I have this ticket database, which we saw in Glue, and I'm able to write native SQL, right? So what I'm gonna do for a second is let me get a couple of queries, and I wanna just go ahead and run some, just so that you guys can kind of see it in action, what we're able to do here. But before I do that, there are some settings that I have to create. So let me go here. The thing about Athena is that when you run queries, those queries get saved in an S3 bucket, right? So every time you run a query, it saves the output. So first things first, I got to go ahead and make a directory that I want to use for Athena. Let me go to S3 and let me go ahead and do that. All right, so what we're going to do here, we're going to go into our handy dandy directory. And yeah, let's go ahead and just make this right here. We'll just put it at the top of this folder. We'll call it Athena query. Athena Athena, spelled it right. Athena query, okay. And let's save it. Let's go ahead and save this. Here's the path, so we'll copy this down because we'll need it. We'll save that. Go over here. Let's look at the settings. Go ahead and configure this directory. So we'll say, hey, look, whenever you're done, outputs, let's go ahead and put it in this directory. That way I can go back and look at it and do what I want with it. So, all right. I believe that is all. Yeah, double check. Oh, and I have to put the thing behind this one too. Almost got me. Okay, so yeah, that's an important thing. I think I got stuck on that before. When you don't include this backslash, it'll barf at you, and it'll make you feel really crazy. So just make sure you complete the file path. I ran into that issue before, and it was pretty interesting watching me bang my head over the wall with something so trivial. Awesome. So let's, now that we have that configured, let's go ahead and open up some tables. So let's go ahead and open up this sporting event ticket table. As you can see, I have, the new data types. Remember, we changed these: ticket holder ID, sporting ID. So all of that is reflected natively as if it was a a regular database. And this is just using that glue catalog, right? So there's really no schema. It's a logical schema. Let me go ahead and get a query from Athena for a second. I have to type it. I don't memorize the actual query that I'm going to run. So I'll just grab the cheat code, copy this guy, and we'll go ahead and put this in there. So, cool. So if you look at this, it's native SQL, a SQL language, right? So for all of you who are comfortable with SQL, this is pretty much right up your alley, same experience. So there's no learning curve with using Athena. It's just a different way to query because you don't have to stand up any infrastructure. And you have this integration with Glue where you can kind of do things on demand, and it makes it a lot easier for ad hoc analytics. If you're going to have like a data warehouse, I wouldn't recommend it because the cost model is not favorable in that kind of workload. We do have data warehouse solutions that are more fit for purpose, but from an ad hoc standpoint, you just want to get some insights from some logs, maybe. Athena is you're one of your best friends. So if you look at it, so you saw it kind of spun around a little bit. Look at my data scan. So I only scanned 12 kilobytes, right? Tells you how many runtime, how many seconds you ran, the query ran for. And then you get to see your data, right? And you can do everything in this as you can do in SQL. This is a pretty big table. You can do everything in here as you can do in SQL. So you can create views. You can load views into dashboards, like our version of our dashboard solution, QuickSight. I don't have enough time to demo that piece, unfortunately. I don't want to cram too much, but, I can basically save this query as a view, right? I can basically create a view from this query and then use that within a dashboard. You can also have, pseudo real-time dashboards that get updated by APIs. So there's a lot of functionality and flexibility when you have this sort of decoupling between how you process your data pipeline, because it gives you that flexibility to, for whatever use case, I may have a real-time dashboard. I may have a, pseudo real-time dashboard, or maybe I have batch, right? But the way I'm feeding those downstream systems is unique for the use case, right? I have very specific ETL. I have good visibility over my ETL. I can create event-driven ETL. And that gives you the ability to innovate, right? You get the ability to innovate faster. You don't create these bottlenecks within your organization. And it gives you that, agility, right? So imagine a sales team and a marketing team, doing their own ETL, and then they join their data to, talk about, to produce some sort of holistic look at data, right? So even siloed organizations can build their own pipelines and still produce consolidated artifacts that, are usable by the business. So there's a number of different ways you can skin this cat. Again, I don't want to drown you in the slide where I just kind of wanted to show you just so that you can see how quickly it can be done. I mean, this table again has, let me go ahead and actually show you. It has a couple million rows in it, so it's actually pretty massive. So this is not a Hello World database by any means. This is actually a real and live table. So if you look at my rows on the right side, I mean, you can already see, right? We got 15 million rows in this thing for this table, right? So this table is massive. We have 7 million in this table, 1 million in this table, and it scales great. ETL, I mean, you couldn't even really tell that I had this much data. I mean, the cold starts were the longest part, but the execution was rather quickly. It's just obviously that cold start. And again, just another plug. I did a session in which other participants, it was 80 people that joined the session that we hosted externally through AWS. And they all were hitting my database at the same time. So I had at least across the whole session, like 100, I think the maximum was 150 concurrent database connections at one time, and the RDS database didn't choke. So just a shameless plug to the database solution that we do have. It was able to let multiple accounts stream or batch ingest its tables without choking, right? We had over 100 connections to that database, and it performed well. Everybody was able to load their data. There were no hiccups. So again, across the platform, you'll see this ability to scale and the ability to manage high demand and high load. So just keep that in mind whenever you're thinking about any sort of futuristic or strategic applications. Definitely confer with us if it's something that you're willing to do, and we can definitely get you in the right place from a strategy standpoint. So with that being said, Justin and Jeremy, I'll turn it over to you guys, or Greg, if you have anything you want to add. But I feel like this is all I really had have to present, and I'll just leave it there.
All right, great. Corey, thanks. That was terrific. So yeah, we've got some time remaining. We'll turn it over to the group while we've got Corey and company here to chat with us. What questions do you guys have? So anybody out there already employing any of these concepts in your shops, or anybody with near-term objectives where you think you might be able to employ these? Questions, or we'd also love to hear what people in the community are doing and share some of your objectives and some of your ideas.
Sorry, I'm pretty much missed the previous meetup about the data lakes in general, and it seems like this is the technique that was shown today. It was something that helps to first of all, just huge relational databases problem. They just keep growing, keep getting bigger, and it's like RDS prices every month bill just goes higher and higher. So yeah, from one side we can just do partitioning, right? To cut the old data off and everything. But from other side, we also value the data that is inside. And from this perspective, we need some kind of store that data. And the question is how to store this data, store it just the raw data in this old database, or just process it somehow using this tools and have a already processed data with all this results, and just right. So do I understand it correctly? The whole idea of this.
So you have it down. Let me kind of augment that a little bit. So I'll give you an example. Let's say you have an ERP system, right? You have SAP or Salesforce, some system managing inventory for your business, right? You have a bunch of data around inventory, sales, a lot of business critical data. And let's also say, you have, a team that is working on social media analytics. So they're trying to understand what people are saying about your business and kind of tie that into the way your business is performing. So what you'll do, or what you have the ability to do, is say, okay, I have this existing ERP system, right? So I have my SAP or my JD Edwards, and now I'm going to bring that data into Amazon, right? So that would happen through, a migration tool such as the one I didn't show, but I used, in which you would keep that SAP or that JD Edwards, the ERP data, where it resides, but you replicate it into AWS, right, with the managed migration tool. And that data would land in S3, that data lake, right, that object store foundation. And then from there, you can build your logic to compress it, right? And then now you can just use the compressed data, so that way you can reduce your footprint. And then in tandem, your analytics team, right, who's doing the social media scrubbing, and they're looking at comments on Twitter and Facebook, and they want to see what feedback customers had. You can then have that team in tandem load those streams of raw data, right, that is uncurated, because, when you talk about an ERP system, by nature, it's highly structured. So you're kind of safe there. But when you talk about like analytics on the mobile or web, those formats can come in multiple flavors. So in that use case, that team would be able to use a service called Kinesis, for example. It's a streaming service that we offer, and they'd be able to essentially produce data into AWS, into S3, right? So they can have an application that they build that produces data and feeds it directly into the AWS environment, as well in the data lake. And it's going to be logically structured based on that data domain. So it won't be structured with the SAP or ERP data, because they're different. It'll be in its own logical structure outside of that. But the power of the data lake is that once those are there, and you have that pipeline where either it's real time, it's batch, it's on demand, that you load this data, because you're applying that compression, you're reducing your data footprint, right? So you're not exponentially growing. And you have the ability to now do advanced analytics, right? So if you have a team, a forensics team, like a data science team that wants to really do some rich forecasting about how they can improve customer service, or, understanding the impact of, feedback from customers on the product sales, for example, you have that ability because those data sets are in AWS. You fed them in, you've applied a logical schema on top of them, right? And now you can feed them to other platforms like the one I showed, or we have other ones that are data warehouse solutions like Redshift. You can feed them into our machine learning platform, SageMaker, and your data science team can build and train their own models. We also have abstracted AI services that don't require you to understand, machine learning, where you can just load data into it, and you can take that data from S3 and just load it into, for example, Amazon Forecast, and it'll forecast a value that you specify based on what data you give it. So that's kind of how I would think about it is, again, the data you currently have would still remain in most cases, but you have this ability to maintain, the lineage of all your data, but while reducing the footprint and enabling, synergy across multiple work streams for your internal teams.
Okay, thank you.
Very good. And I saw we had some conversation going in the chat. Greg, thanks for hopping in with Kimberly Glock on that. Anything that was kind of a side conversation going, just anything you guys want to, any further discussion or anything y'all want to add about the Kinesis versus Athena conversation?
No, so I think the important thing is, right, and so Corey spoke about it with Sergey also, is think about it as a much larger problem that you're solving. So you have all this disparate data from all these different sources. And what you're doing is you're putting them into a single location, and by using Glue with the crawler, you're able to get some indexes, right, to get those meta catalogs. So you can now do those queries across sources that are not typically easy to do. So for instance, he was talking about a Kinesis stream where you just have S3. It's basically a flat file. And then you have a database where you're dumping, or an ERP. And so being able to query against those different types of data is not something that's easy. And that's really the strength of using a data lake, and then using Glue to build that catalog, and then Athena or other tools to be able to query. So I hope that makes sense. It's a lot larger, and it's things that people, some people have never thought about, right? And didn't realize, well, heck, I can do that, right? I can get data from my social media. I can get data from my ERP. I can get data from my sales, or I can get data from potentially my source code repository, right? And get all that information together and be able to do those queries. Hopefully that makes sense to people, and it's starting to open their minds to what is possible.
Appreciate that, Greg. That was very timely. One example, just to kind of throw out there too, when you think about like manufacturing customers, you know, one trend that we're seeing is that they're collecting a lot of sensor data, right? And now they're, you know, manufacturing providers, or, you know, folks who provide services to other manufacturing customers in the realm of analytics. They're looking for a way to manage that scale, right? So they have a lot of producers, they have a lot of, you know, brown mills, and they're trying to understand, hey, how do I manage a data pipeline so that I can provide services or intelligent services to my own plants, other plants, right? I can sell it as a service. And that's where the data lake comes in, right? Because now you have the ability to segregate, you know, these data flows. And, you know, some customers say, hey, well, I don't really have that much data, right? I only have a couple of gigs, maybe 100 gigs, maybe 1 terabyte total. The power is that because this is a serverless platform, there's no pre-provisioning of costs. So you don't have to allocate, you know, hey, I need this amount of storage. You pay for what you use. So if you literally only use, you know, 100 gigs, then, you know, you might just pay a penny or so. I'm just kind of throwing it out there, but, you know, you kind of get the gist, right? There is no requirement from a data footprint standpoint that says, hey, you have to go data lake, or hey, you definitely cannot go data lake, right? It's a good structure. It's just all about patterns, and it's all about building yourself for growth. And because, again, these resources are, you know, serverless, consumption-based, it kind of bodes well with that ability to kind of make yourself ready to grow when need be. But, you know, for the current time, you can, you know, be very cost effective and have minimal cost.
And I saw Kimberly had a follow-up question. Kinesis queries, SQL for streaming data, and not Athena, correct?
So there's a couple pieces on that. So there's a lot of flavors of Kinesis. Kinesis does have, and Greg, keep me honest, Kinesis does have the ability to do real-time querying with SQL. I think it's called, it's a different version of Kinesis. I forget the actual name. But yes, with Kinesis, you actually can perform real-time queries. There's Kinesis data streams, which is just, you know, statically landing data in S3. You know, you can, and then there's the, Greg, do you happen to know the name of that Kinesis service, by any chance?
There's the data analytics. So what I was doing, Kimberly, was I was going to read through our documentation to make sure I got everything straight. So so my thought pattern is I use Kinesis if I have a data stream. And so if I have that data that's streaming in. Once I've stored it and I've kept it and I want to go back and to query it, I typically use Athena or another tool to be able to do that. And I'm just looking to make sure, is it as clear cut, or is that more around my best practices? So if you look at Kinesis data analytics under the FAQ, it talks about you're using a stream, right? So you open up to a stream to get that information. And so it can be unstructured data, right? Which is helpful because, you know, as we were talking about before, how's that data coming in? Typically it's IoT or some sort of log data is usually what Kinesis is used for in my experience. And then depending how I need to bring it in, if I'm going to use data streams or if I'm going to use data fire hose for the input, and then data analytics to do the processing. So as with most things in life, it's not black and white and there's only one solution to do things. There are usually multiple ways to do it. And so from best practices, what I look at is kinesis is if I have data that is streaming in, and I want to do something in real time. And if it's not real time, then I'm looking at Athena or some of the other tools that we have available. Does that help answer your question, Kimberly? Oh, it makes sense. Well, good. I'm glad it made sense. So that's what we will now call fact, since we've all agreed. So, but thank you very much. All right, I'll turn it back over.
Appreciate that, Greg.
Yep.
Appreciate that. I think I'm all set. Jeremy or Justin, if you have anything else.
Yep. Just want to thank everybody for coming in today. Before we leave, everybody stick around for just a moment. Everybody who stays around to the end, of course, eligible for Trend's door prize for the month. So Justin will be awarding those momentarily. Also, just a last call. Anybody who wants stickers, either email us at bhmaws@gmail.com or fire over a private message to Justin or myself, and we'll get those out in the mail to everybody in the next day or two. We'll follow up to the whole group with that full rest of the year slate of events. We'll be posting that publicly in the coming days, and hopefully more announcements to come. Be sure to follow up with us on ideas, requests for speakers, or any calling for volunteers coming up. With that, I will hand it over to Justin for this month's swag award.
Yep. Thanks, everybody. I did a thing this time since somebody jumped off the call too fast last time. So I PM'd everybody a little bit before everything ended, and we've got our 4 winners already, and they've sent me their email addresses. So thank you to Jerry Smith, Ben Carlisle, Sherry Ross, and Matt Neighbors. Thanks, you guys, for being our random folks this time. And in the chat, I put a link to Trend Micro and our AWS page. And then I also put a GitHub link to links for a talk that Chris, who's going to speak to our group in July and in November, he's also going to do this coming Tuesday, a migration of either a Python or a Java C# app to containers and Fargate. And so in that GitHub will be the stuff that you'll need for the talk. It's very technical, so if you don't know how to use GitHub and things like that, it's not going to be a fun Tech Tuesday for you. We're not going to listen to somebody drone on and on about their startup for once, so it's going to be pretty cool. And yeah, keep shooting us emails and stuff for the stickers. We've got tons of stickers and swag. Love AWS, love supporting this group, and I love just seeing it grow and everybody doing what Jeremy says. AWS is Legos for adults, and it's awesome.
All right. With that, we will see you next month, July 30th, with Mr. Chris Chapman when we do a .NET Elastic Beanstalk deployment. So thanks everybody for joining today. We'll stick around for a few minutes to collect these addresses out of the chat, and we'll be watching that BHM AWS at Gmail address for any follow-ups. Everyone have a great rest of your week.
Thanks, guys.